Hello everyone. We'll start in a few more minutes. Um, if you are able to hear me, if you're not able to hear me, please uh, type in the chat. I will have a look. Please, everyone, if can confirm you're able to see my slides. We'll start in a few more minutes until more people join in. Um, okay, we will start in a few more minutes. For new joinees, please confirm if you're able to see my slides and also hear my voice. Uh, if you have any questions or if you're not able to hear my voice clearly, feel free to type in chat. I'll have a look through it. Okay. So people are still joining. So while people are joining, so I would like to, I mean, there might be some new students who has joined this week, uh, who haven't probably joined last week. So I wanted to introduce myself. So I'm acting as a teaching assistant for this course at NPTEL. And a background about me is that I'm a PhD student at IIT Bombay, Computer Science Department, and I'm in my fourth year. And I'm currently a Prime Minister Research Fellow, a PhD student. So I'm uh, doing a teaching assistantship for Python for data science course next semester. So my research works are on AI and language models and using machine learning techniques to build better efficient language models. So with that, I think we'll probably start now since many people have already joined. And if there are any questions, feel free to ask in the chat. There is some voice breaking. Okay. Yeah, please feel free to type. I think if there is, if you're hearing any breakage in voice or something, try rejoining once. I think at my end, the internet is working fine, I think. So I will still try to see if there are any hiccups, please let me know. I will adjust based on that. So thanks again for joining everyone for this course and for this tutorship, this teaching session today. And we will do today week 2, which is our Python for data science course on sequence and data types, collections, and NumPy. So it includes more about strings, lists, tuples, and all those things. So we will discuss all those things today. And last week we had discussed about something on the code platform for using Python, like Visual Studio Code or Spider and all. So we had so it's on YouTube right now, so you can go and check also that video if you have joined for the first time this week. And so last week, I think, as per the course details, we were mostly looking at variable assignments, setting up how to set up Python on your local computer, desktop, or and different such platforms like Jupyter Notebook, VS Code, and Spider, different aspects of it. So today we will discuss about the second half of this uh, meet of this tutorial, which we will look at the following about sequence data types, different types of data types in Python, which like which has a behavior property of sequences like list, arrays, strings, and all. So we'll look at those aspects today. And if there are any questions, feel free to ask in the chat, and like I'll try to look at it as and when there is some intervals during the entire 2 hour session today. And we will try to see if we can get some kind of if we can get some kind of tutorial kind of questions solve like question solving sessions today, if time permits. We'll try to do that. So okay, so I think yeah, so the link for the last recorded session I will share in the chat. I think even from the PMRF course session, I think that would be shared with you also uh, from the NPTEL platform itself. So okay, so I think with that, I will try to move ahead with the course contents. And so, okay, so we'll first discuss about sequence data types and all. So, what are the outcomes of this thing out of learning these concepts? So, you would try to recognize different concepts in this course. Like you can classify this Python containers by different like kind of sequence data types by order, this property of mutability and uniqueness and all. So, for example, I'm just giving a very initial discussion about sets. Sets is a particular data type in Python, which looks at unique list of numbers. So, so none of the numbers are actually repeated in a set. So that is uniqueness, or you only have unique numbers in that set. The second thing is about operating in Python, like syntax, different aspects of index, slicing, how to update items in a Python array or list or set, iterate over it, search, sort, and all those operations. The third would be to look at what is the right structure for storing this kind of different kind of unstructured data, like text, records, and all those things. So for a very useful motivational example is this, that Since in AI, everyone knows that they are trained on a large sequence of data and pre-training corpus and all. So what sort of data structure should you use to um, sort of store such huge text records and all? So the different combinations of this sequential data types can be used there. So we'll look through those things during this slide talk. And the fourth one is about NumPy, which is a library and which is useful for also for computing this scientific Python kind of work. For example, if you want to do some kind of aggregation across items in an array, or want to use vectorization concepts and all. So those things this library provides. So we will discuss those aspects in this course session today. So yeah, so I hope yeah, I will share the slides at the end of the talk, and also the recorded videos would be up. I will share that channel at the end of the talk or somewhere in the middle of the talk, so that you can have a look at it when you can. So I think probably mid of next week, I think the YouTube video will be out. So for this particular session, I'll share the previous one over chat at the end of the talk sometime. So we'll move ahead. So I'm just giving a brief sort of time break of the entire thing. So we'll first 5 6 minutes. I think although we have kind of gone past 10 minutes now, but 5 6 minutes we will look at the foundations of this sequential data types like terminology, operations, and decision criteria and all. And then we'll look at the basic containers itself, like string, lists, tuples, dictionaries, and all. We'll look at by explaining the concepts, and then also look at code, and we do a practice session also. I have kept a break of for doing some kind of quiz kind of setting, but we'll try to see if we can do it during this session. It should be mostly 5 minutes. So just during the session itself, we will discuss that. And lastly, we will look at NumPy, the library itself, for looking at creation, indexing, and all. So if I'm going fast, please feel free to type in the chat. I will manage the time based on the pace of the talk. And if there are any concepts that you are not able to understand, or you want to like understand once more, feel free to let me know in the chat. So I will probably look at chat in the next 10 15 minutes, but feel free to add your questions if you have in the meantime. So yeah, so I think uh, just doing a live kind of short recap of what we had discussed previous week. So if you already have a platform setup at your end, like VS Code, Spider, any of these platforms, or even Google Colab or Jupyter Notebook, feel free to just maybe open it during the session itself. You can just do it on the run, because it would help you to understand the concepts a bit more while you type in from your end also. And so use Python 3, because Python 3 is the latest Python module. And so Python 2.7 and all those things are also there, but these are kind of more sort of like yeah, so these are sort of like more kind of the previous libraries have kind of some conflicts with different newer versions of the Python library. So the advice is to use Python 3, and use a recent NumPy installation which is compatible with Python 3. So we'll discuss those things when we get to NumPy. And so the useful way to for anyone who is starting out with Python, the useful way to is to start with a logical block at one logical block at a time. For example, there are many things in Python like for loop, if else loop, and all those things. So you should only focus on first completing one logical loop on one logical block at a particular time, and you should inspect that everything around that block, because as you know, like if there is any error in a particular block, it would kind of flow into the next parts, and it would like at the end when you're when you're shipping your code or kind of testing your code, you'll not be able to find the exact bug where your code had an error. So it's always useful to do one small specific block that you are writing in Python at a time and inspect and test and debug for that. And as we had already discussed last week also, so these are like symbols like hash, which marks a start of a comment in Python, and the output usually is shown below like this. And it depends on what platform you're using. So if you're using VS Code and all, so you get the output in the terminal. If you run it other Jupyter Notebook and all, you actually get directly below the cell where you are running the code. And lastly, the useful convention is to use snake case. Also, there is camel case also. Camel case usually is preferred in C, C++ mostly, but you can also use snake case and camel case here also. So yeah, so we'll now look at the terminology aspects here. So one is the sequential based data types. So sequence, what does what what does it come to your mind when you think about the word sequence? So basically that means that there is some kind of ordering or in a sequence there is a list of some items, let's say. So any ordering kind of aspects we can think of it as a sequence, which means basically there is a position associated with each item in the data type. So typical examples are like string, list, tuple, range, and all. And we'll look at why this position is important because, so for example, in indexing is a useful concept in Python. Um, okay, so there is some voice issue. Okay, if there is a voice issue, please also confirm in the chat. You can try to see if there is any issue with the mic or something. Okay, so I think with that, so with string, list, and tuple and range, they actually have this ordering because we can index an item in the string, list, anything with the corresponding position of that element. So these are like sequences. There is another concept called mapping, where you have a key value based uh, kind of data structure. So you can access the values via the keys. So you query using a key and you get back the value. So typical example is a dictionary in Python. The last one is called set, which is a membership based kind of data structure. So as I mentioned, like sets have this unique property of uniqueness. So you can only have unique value in a set, not multiple values in a set. So because they store some unique hashable values, so it's not, and you also can't index or slice a set. So we'll look at the definitions of indexing and slicing, but so this basically in set you can't actually index using the position of the item in the set. So you have to kind of query using the key and you get back the value. So we'll look at those examples. So these are kind of typical operations that are kind of shared across different sequence types. So for example, length is basically means that the number of items in the data type. So len of x is basically, for example, x is a array or something of list of, let's say, 4 items or something, then it would give me 4. It's a string here, so it's not an array. So it gives me the number of counts of the characters in the string. So you can also index. So you can get the position and index that element. It returns back your corresponding item at that position. You can also do slicing. That means you have this entire string or this entire data structure or data type, and you can actually give any two positions in the data type, and you can only retrieve those values within that position. So it's like a subsequence of a bigger sequence, or you can think of it like a subset of a bigger set, let's say. So like this, we'll look at each of these examples in detail more, but it's just a preview of what kind of operations are there. So there is also membership, concatenation, repetition, and all. And also lastly, there is concept of iteration. So this is useful in kind of for loops, and if you want to iterate through items in the data type itself, how to do that. So all these things are important aspects in operations in this kind of sequence types. And so we'll look at this particular slide a little bit later, because I think this might be a bit detailed and may not, for people who are getting introduced to this topic, this might not be directly understandable at the first glance. So I will come to it later on. So we'll try to motivate, like in terms of what kind of sequence shell data types can you use in during your kind of sort of project or any kind of application that you're building. So given, let's say, you have to figure out what kind of data you have. So it might be a text kind of data, or you can have some kind of name fields, or you actually specifically want that your data should have unique items, or like there it should be kind of arranged by some kind of unique key or something, or it can be simply a numbered list or something. So if it's a text, you can consider a string. Named fields, you can consider a dictionary where you have a key value kind of thing. Unique items, you need to have a set because you don't have multiple entries in a set. And numbers, you can have any sort of array. Specifically, NumPy is a library that provides you different operations on array. So you can use a NumPy multi-dimensional array. So ND array basically means multi-dimensional array. So if it's an order items, if you want to change it, like in terms of, let's say, add new items or delete new items, or change the ordering of some of the items, you should consider it as a list. Is one of the data types that you can use to have this kind of functions. If you have a fixed record which you can't update that much, then you should consider a tuple. If you have an integer pattern, like let's say kind of range. Range is particularly the data type, basically like a continuous spectrum or a discrete spectrum between one integer and the some other integer. Let's say 1 to 10, like all the numbers from 1 to 10. So you write it as range 1 comma 10. So it gives you a list of numbers from 1 to 10. So this for integer patterns, you can use it like this. Or if you want to have a 1D array, then you can use NumPy's again array data structure. So we'll first look at a string, which is a useful concept in this kind of work. So I'll just, I think some people are more joining in, so I will just, okay. Yeah, so we'll first look at strings, which is a useful data type in this series of sequential data types. So these are called immutable sequences. So we'll look at what it means. So by this end of the session, you look at how to create a string and also index and kind of transform from textual kind of data to a string format. Also, how you can do different kind of formatting operations to make it readable, sort of. So the typical examples I have pushed in the right-hand side of the slide here. For example, Mumbai in within these codes is a string here. Message like Python is fun is also a string here. All these things are typical examples of string. So single and double quotes behave the same in this aspect. So use the other quote in a string, or you can also escape with a back slash. Triple quotes, if you want to use line breaks, let's say you have a long paragraph of text and what there is different line breaks, you should use triple quotes there. So this variable here multi-line uses triple quotes, which and there is a line break that you can see here. And so there are different aspects of it. So there is also this R, then double quotes, which basically creates a raw string, and you can use it for passing your file paths or folder paths and all. And you can also use it for regular expressions also. For example, any sort of star, something dot. Uh, so if, for example, if you want to find some uh, pattern, let's say in a string, so you can use R dot within double quotes with the corresponding this thing. So let me get back in a moment. I think there is some network issue. I'll just there's some. Uh, yeah, sorry, there was some network issue. So I hope everyone is able to hear still. Okay. So moving forward, sorry for the disruption. So I think these are different examples of string here, which I'm showing here how to use and create strings in this aspect. Now, I want to show you an example how you can index in a string. So what do you mean by index? Basically, you give a position of an item in a string, and you want to show that how to retrieve that item from that position. So, for example, I have this string here called text equal to Python, where I have uh, like this is just a simple double quotes string. That's all. Now, what I want to do is that I want to retrieve, let's say, the second item in that string or the third item in the string. Let's say I want to retrieve the letter Y or letter T, let's say. So typically in Python, it starts with zero indexing. That means the first letter in the string P starts at index zero, and then the second letter starts at index one, and so on. And since there is around six characters in this particular string, so it starts from zero index to goes to five as my maximum index ID. And so if I want to do, let's say, a text zero, I would get the first uh, letter T, which is residing at position zero. Similarly, if I want to do text two, basically means I want to retrieve the letter T, which resides at position two. So there is now this interesting aspect also. So you can also do in a reverse fashion also. So the positive indices like 0 to 5 starts with left. So you can count from the left and you can retrieve letters and characters from the from in this way. But if you want to actually use it from the right hand side, like if you want to kind of retrieve from the like you want to use an indexing pattern from the right hand side, so you use negative of this thing. So basically this means that you can think of it like this, like you went to the last end of the string and you want to backtrack, or let's say you want to do a previous step, so you do -1. So you can think of a kind of a pointer at the end of the Python string here, and if you do -1 you get to the last character, which is n. If you do -2 you get it to o, and so on like this. So so at the end of the string you can think of it there is a index marker or something, and if you take negative steps from that index marker, then you can retrieve also from that thing. So this is useful for different reasons. For example, you don't know, let's say there's a long large paragraph in a text setting, and you don't know like which like what is the entire length of the string or something, although you can do length of the entire string and you can get the number. But let's say you don't want to do that and you want to just retrieve the last let's say seventh item in the text, let's say. So you can just do that thing of -8, let's say. So you get that thing instead of doing all the calculations of calculating the length and then going to the last eighth position. So you can also get a different particular kind of error in Python called index error. If your position, the kind of position that you're putting in the field here is outside the valid range. So if let's say if you put text of 7, let's say, then it's outside the valid range, so it gives you an index error. This was about indexing. Now coming to slicing. So slicing is also an important operation as I was mentioning. So it gives you a subsequence of a entire sequence. So for example, data science is my entire string here, where each item in the each letter has a corresponding index to it. Now, if I want to just retrieve the subsequence TASC, which is a subset of the original string, then I can just index that using my start and stop kind of thing. So I have a sequence, I have a start ID and a stop ID, and I also have a step ID. So this basically means that by how much jump size I want to, or how much intervals I want to do this. So everything from start is just included, and the stop doesn't. Everything at the index at the stop doesn't get included. So an example is shown below. So this S is equal to a data science, and S 2 to 6 basically retrieves me the items at index 2 to 5. So this gives me a TSC. Now, if I do colon 4, that means it starts at 0, index 0, and retrieves item up till 3. So DAT data. So data is the one that I'm getting. Similarly, like this for all the items, if I don't specify start and stop, it will just assume start is 0 and stop is 10, which is the end of the list. And I now give a jump or a step size of 2. So it would give me T and then T and S and so on like this. So it won't actually give me the consecutive elements, but the at an interval of 2, it would be giving me the items. So these are the concepts of slicing here. If there are any specific questions you might have, feel free to let me know. And yeah, so moving ahead now. So this was about indexing and slicing. Now comes different operations on strings like um, concatenation operations and or kind of membership test and all. So if you want to concatenate two strings, let's say I have first equal to data, second equal to science. Now, if I want to add these two strings together, that means I want to have data science as my entire string. What I can do is like I can do first plus, and I can add a small gap as a string, and then I can add second. So it would club the two strings together and would give me data science as my final kind of string. Now, if I want to repeat a particular string multiple times, so for example, HA is a string, and if I want to repeat 3 times, it would give me haha follow as follows. So likewise, you can do this kind of operations, although these are arithmetic operations. And this we had discussed a bit in our last week session also that it might for first timers it might seem confusing because this is an arithmetic operation and and the operand is a string. So how is it possible that you are able to do this? So this is a very useful kind of functionality in Python that allows you to use this kind of operations like plus and star with strings, and this gives you this kind of the output is also a string in this case. And so this is the thing. So the third one example is called membership. So for example, I want to see if SCI is in second. That means whether SCI string belongs to the string signs or not. So it gives me true false because it's a Boolean parameter. It gives me whether that a subsequence is a part of the sequence or not. And third, this is basically so as I mentioned, comparison is kind of lexicographic and as well as case sensitive. So capital D data is not equal to small d data. So that's why it's since it's case sensitive, it gives me a false answer here. And yeah, so I think these are very kind of easy kind of examples here that I'm showing just to motivate the different operations here. But you can also think of some complex examples to try out where this would be present. Now the concept of this thing called immutable or mutable is what we want to discuss now. So we uh, uh, we want to show that why strings are immutable. So what do you mean by immutable? So I have given an example here called this particular string word is equal to cat. Now my goal is to change the first letter in the string cat to B. So instead of cat, I want to make it bat, let's say. But this is not permissible in case of string. You can't change the string structure like that. You can of course add a new string to it, like kind of do an append operation, which is basically add a new string to it and all. But you can't actually modify the original string itself. So this is what is called immutable or immutable property of that data type. And if you want to actually transform, what you can do is like this, that you can generate a new word. You can add B at the initial position and you index it from the second position. So you do indexing from index 1, so it gives me 80, and you are adding B at the first starting of that word, so you get that as the new word. So the original cat remains unchanged because this variable word actually is not changed. The variable, if you print word, it would still return you cat itself. It won't return you bat. So you're not changing the original word. You are actually just creating a new word, and which is a new variable, and you are just assigning that. So that's what immutability means in case of strings. There are some data, sequential data types which are mutable, which we'll look at. For example, list and array and all those things, which are mutable, and you can change such aspects in the string. So so now I think these are like very small examples here, which may not be important right away right now. So I think if you want to, let's say, given a string of text, let's say you want to remove white spaces, so you use something called strip, which basically strips the entire string and just gives you back the corresponding actual keywords actually. So for example, data science and Python. So you can actually also use a pattern or a particular character within strip also to strip. Like if you have a comma or a semicolon, you can also use that. So it strips the entire text along that specific character. You can also do uppercase and lowercase of the string by using dot lower and dot upper. You can also do replace, which is an operation where you can sort of replace a particular subsequence with the corresponding another subsequence. So if I have data science Python, what I am doing here is I am converting this to a list actually. So raw dot strip dot load actually gives me a list of uh, this strings, which each item in the list is basically data science and Python. And now that replace operation actually just replaces that item with the new item, which is gives me numpy, and likewise like this. So we'll look at list operations next, I think, which would make it more clearer about these operations. So as I was mentioning, like split actually gives you back a list. You can also split using a comma as a kind of a splitter pattern between in this list. So it gives you a list of Asha 72, 88, 91, which is basically different items in the list now instead of full string. And so parts is basically the variable parts is now a list now, which is shown in the output here. And if you can kind of index it now also. So first item in that list is Asha, so you get a name as Asha as shown here, and then the corresponding scores are not. So yeah, so I think going to a kind of sort of a small kind of exercise here, let's say. Um, just check. Yeah. So let's try it out a bit. So given this raw record like this, so it's my name and then 87. So you want to remove the surrounding spaces like this. You want to split on the commas also, and you want to normalize the name to title case. and the score that you have, which is 87, which is actually a string, you want to convert it to an integer, and you can also use an f string. So I think I have written it a bit of kind of hints here which you can use, but this is a very simple example you can try out to kind of understand how these things work out. So if you want to take out some 2 minutes time or something to just to think about how to run this thing, if you have your VS Code or platform open, so you can try it out. We can take 1 or 2 minutes on this particular example and then move on to the next piece of slides. And also, if you have any questions, feel free to ask now. I can take it up right now. So, okay, I think so. We can move ahead given the time constraints. But if you are able to solve it at your end, you can. It's good, or you can note it down for the time being, and you can solve it later on. I will also try to share some kind of this kind of practice problems that you can try out at your own time at some point after the after the lecture and during the week, which you can try out. So there are many platforms such as Geeks for Geeks, as well as you can also try out on HackerRank this kind of problem settings, this kind of problems. So I would highly suggest to look through them also. So this should give you, apart from the definition and the kind of the theory part of it, it should also gives you hands-on practice also that you can try out. So moving ahead, so we now look at lists now, which is particularly a mutable operation operation as compared to strings, which was immutable. And you also have this ordering aspect associated with it. So you can have in which order you want to have items in the list. So you can create a list. We'll look at how to create a list, index, slice, and also update a list. Let's say you want to add new elements to a list, how to do that. That is many methods associated with lists that are there. So we'll look at those things, and then we will look at like list comprehensions and all those aspects also, which are particularly important for large items in a list. So we'll first look at creating and indexing and slicing. So typically a list consists of values of different types. So you can have a string within a list. You can also have integer or a Boolean variable in a list. So scores, for example, is a pure integer list which consists only of integer numbers. Mixed is a example where you can have a string as well as integer as well as Boolean variables, and you can actually index each element in such a list. You can index via the position, let's say. So any guesses like what is the length of this of the third list, of the second list, which is mixed? What is the length of mixed? Any guesses? You can comment your answer on the chat. I think just to see if you are able to uh, follow with the pace of the slides and all. Yeah, so one person has answered. Anyone else wants to try? What's the length of the list mixed? Okay. Yeah, I think all of the people have correct their answers. So the length of the list is three because there are three items in this list. So not to confuse here, because the string is considered as one single item in the list. It's not the entire character counts that should be considered. So the string as a whole is an item, and length of mixed or length of that list mix basically means the number of items in the list. It's even if one of the items is a string, you should not be counting the characters in the string. So that's overall about indexing. And slicing as shown in string also, it gives you a new sublist or a new subset of that list. You can also have something called nested list also, which is very like a very kind of unique property of list also, where you can have a list of list also. So given a list of items, a particular item in the list can itself be a list also. So it's a very useful property, and it's not something that other data types actually share like this. So although dictionary will also see that there is you can in some aspects create some kind of nested dictionary also. So these are kind of the aspects. So nested lists are actually useful when you want to actually represent, let's say, tables or matrices. So, for example, as many of you already know about matrices, and also there is like two-dimensional matrices. So, yeah, so I'll come back to. So there is a question: what is nested list? I will come back to that after this aspect. Matrices basically means that if you consider a two by two matrix, let's say, and I will actually give you an example of nested list using this only. So if you consider two by two matrix, let's say A, B, C, D, where A and B are sitting at the top row and C and D are sitting at the bottom row. So you can construct a list like this where you have AB, which is a list itself, as the first item in a outer list, let's say. So you can think of it like this. I'm not writing it right now. I'm just explaining in Word. So it might be difficult, but try to follow the idea here. So what you can have is that you can have a list where you have two items in that list. The first item itself is a list also. So that A and B is a list in the which acts as a first item in the outer broader list, and C and D acts as a second item in that outer border list. So you have a bracket open, and then within that bracket, you have another bracket opens where you have A and B, and the second item in that list would be C and D. So this is an example of a nested list, which you can use to represent large matrices and all. Although you can also use NumPy ND array also, which will look at those aspects in um, okay. With that, we'll move ahead. I think so. These were like about slicing, indexing, and all those concepts. Now, this thing called mutation, mutability, or that we were looking at from strings aspects. So lists are actually mutable as compared to string, which were not immutable. Lists are mutable, so you can actually change an item in a list actually. So for example, on the right, I'm showing you an example where you have a list of integers, 72 and so on. And I want to update the first item in that list to from 72 to 75. So I can just do score 0, which basically means the first item in that list, and I just assign it to 75. So it would easily just update the list with the first item as 75. So these are kind of the operations, and lists actually allow you to change items in position there. So slice assignments can also replace multiple elements. So for example, scores 1 to 3 basically means that index 1 up till 2, which is 88 to 91, I'm just assigning it to 90 and 93. So that basically means instead of 88, I would now have 90, and instead of 91, I will have 93. So I can change also the multiple items at the same time using this concept of slice assignment. And the list length can therefore also change during this slice assignment also. So these are the useful properties in list actually that you can use. And you can also insert new elements in a list. You can extend a list or append, let's say. For example, you have a list, let's say 10 and 20, starting with 10 and 20, and you want to only insert one element at the end of it. Append basically means that you want to add a new object at the end of the list. So you now have the values as 10, 20, and 30. Now you want to extend the list. Now you have this extend operation. Basically, in extend, what you mean is that you can add multiple entries at the same time. So instead of append, where you just are adding 30 at the end of the list, in extend, you are adding 40 and 50 at the end of the list at the same time. So you can add multiple such elements in a single line of code instead of adding multiple lines of code. So I now have in the list as 10, 20, and 30. Extend actually just adds me 40 and 50 at the end. So that's the part. So again, to sort of repeat the same thing, extend is basically like appending multiple items in that list at the same time. Now the another useful thing is called insert. The thing is that, let's say I have a long list and I forgot to, let's say, add an element at the second position of the list. So let's say I already had built a list of numbers, and I forgot to add an entry to it at the second position or the third position. So for that kind of request, you can use insert, where you give the position at which position you want to insert, as well as the corresponding number of the item that you want to insert. So these are like different operations in list that you can use, and these are very much useful in multiple applications. Like for example, you are maintaining a Excel sheet of finance related activities, let's say like bank balance and credit card statements and all those things. So this you can convert these tables and all those things in a list format, and you can also do appending, insert, and all those operations also. So these are useful in those areas. So you can also do remove operations also. So we previously saw about insertion operations like append, extend, and all. You can also remove. Let's say you want to remove a particular element from a list. So what you do is just you specify the item that you want to remove. It just removes you that item. There is also this thing called pop, which is an operation which removes the item at the top, let's say, which is like it's not just a single specific element. It just removes a particular ending item, let's say. And delete actually also is another operation that you can use. And lastly, clear is the operation that you can uh, clears like removes all the items. It gives you an empty list at the end. So these are some of the operations. Again, plus and star are like arithmetic operations that are useful also here. So if you want to add two lists, 1, 2, 3, 4, instead of just adding the numbers like that, it would just do concatenation of those two lists. Like you just add those numbers. It would just add the items in B to the list in A. So you now have values as a list of 1, 2, 3, 4. Now you want to repeat that. So values into 2 you want to do. So you are just doing 1, 2, 3, 4, and then again 1, 2, 3, 4, because it's repeating the items in the list itself. Now into you want to check whether 3 is in the list or not. It's a Boolean variable, so it would return you true. You can also do different operations like sum, min, max. Sum basically means that the sum of all the items in the list. Again, sum, max, and min only works if your list only consists of integer or float. It won't work if you have any of the items in the list as string. So that's a requirement, a default requirement. So otherwise it would give an error. So sum basically means sum of all the values. Max means maximum across all the values in the list. Mean basically means minimum across all the values in the list. Now, index, as I was mentioning, finds you the position, and there is also count. Also, is another operation which will see like how many counts are there. For example, if you want to try to see like how many times a particular item is in the list. If there is a repetition in that list, that some of the items are repeated in the list, so you want to try to see how many counts of that item is in that list. So you can use the count operator also. You can also sort a list. You can do list.sort. So given an integer list, you can sort the list also. And this just changes the list also. And you can also do a sorted also, which is another operation of doing the sorting operation. You can also do was equal to true during the sort operation, and it gives you a descending order sort instead of ascending order sort by default. And so these are different such operations in sorting that you can have. So any questions till now? If you have, before we move ahead to the other aspects of mutating and all those things. There any questions, feel free to ask now. We'll take a short 2 minutes break in that sense. If you have any questions, feel free to ask now. Okay, I think there are some questions which I can address right now. So sorter would sort in ascending or descending. So typically by default, the sort operation is in ascending order. Unless you give reverse equal to true, it would not give you a descending order sort. Uh, yeah. So indexing on the previous slide, how the output of two come about. Okay, let me show that. Okay. Yeah, so this is the slide. So I added two numbers. I get 1, 2, 3, 4 as my final list value. Now I am repeating by 2. So I have this entire list here, 1, 2, 3, 4, 1, 2, 3, 4. So now what I'm doing is that values dot index 3. So it finds a position 3 and it gives me the value. Okay, I think there is an error here. I think in the output there was an error. I think you're right. Should not be 2 here. It should be just the at index 3, like so it's not 2. So I think you're right to point it out. So there's a typing error. Yeah. Thanks for pointing that out. Okay. Now what is the len param and sorted, and what if mixed data is included? Then sorting would be based on what? If you have a string of a list of strings, let's say, then you have ASCII based ascending order sorting also. That is possible. So that is possible there. What is the len param in sorted? Uh, so if I understand correctly, you mean len param basically sorted gives you a list back in the which is the sorted list. Length actually basically is the length of that list itself. So I think if that is what you meant to ask. Yeah, so I think min max won't work for mixed data because you it doesn't make sense to have um, different kind of string or list of lists. Let's say if you have list of lists, then you won't be able to do min max at that point. Okay. Any other questions? Okay, I think we'll go ahead then with the topics. So, coming back to the next set of items, so there is this concept of alias versus copying. Um Although I think this is a kind of advanced kind of part of the topic, so we will anyways see it later part of the course also. But I'm just giving you a brief kind of a concept overview of this. So, given a list, let's say A 1020, I now I'm creating a new variable list called B, and I'm assigning into A. So now if I'm appending a new item to B, so basically B now is also 1020, and now I'm appending a new item to B 30, so it becomes 10 20 30. Now if I print A, so what do you think would be the output? Should it be the original 1020 only, or should it be 10 20 30? So this is a question that we are trying to answer. Um, and so why do you think this is, sorry, I think, yeah. Why do you think this is the case where, and so what do you think, first of all, like whether A should be the original list 1020 itself, or should it be the modified list 10 20 30? Although I haven't modified it explicitly, like I haven't appended 30 to A. So what do you think should be the final output it? Should it change? Should it be unchanged, or should it be having this new item 30 at the end? Any any sort of answers to this? Yeah. So I think I think I have given that answer a bit in the in the diagram itself. So it points to the same object. Sorry, yeah, it points to the same object here, which is 10 20 30, and so both A and B are getting modified. So this is a very unique setting here that happens. So even if you are not explicitly modifying the list, if you are just assigning into a new variable and you are just modifying there, it actually changes your original list also. So because both the names point to a single object, so that's the thing. So instead of that, you can also create a shallow independent copy of the same list. So there, if you make changes and all, you can still, they also still share this nested mutable objects also. So now there is other concept of list comprehensions, which is uh, given. Let's say I will first go through the example here. So given you have this core list, and you want to add 5 to all the elements, all the items in the list. So 72 becomes 77, 38 becomes 45, 91 becomes 96, and so on. So a typical way to do this is to, you can index at each point in the list itself, and then you can add 5 to it. So you can do this for, let's say, 4 times, because there are 4 items in the list, and you have to line 4 lines of code actually for doing this. So it's fine if you do this way, but if you have a large list, let's say you have millions of items in that list, you can't write millions of lines of code just to add a new integer to that each item. So what you do there is something called comprehension, where what we are doing here is as follows. We are creating a new list where each item in the list is added by integer 5 with the expression called for s in scores. So what it does is like it is using an iteration operator over the entire list scores, and for each item in that list, it's adding an 5 to it. So that's my one example of comprehension, list comprehension example. The other one is something like this, like let's say for all the items in the list scores, I now want to see if any of those items are greater than equal to 40 or not. If they are greater than equal to 40, I want only them to return to the new variable passed. Otherwise, I don't return them. So because so now here, for example, I curved was now become 77, 43, and so on. And for scores, because I'm searching in scores, I'm not searching in curved. So I'm searching in the original list itself. There I'm trying to see whether it's passing 40 or not. And there I'm seeing only three items are passing over 40, and so I'm just adding them. And same thing, I can also do some kind of assignment also in the third option, where you can do labels equal to pass if items are greater than equal to 40, otherwise you assign it fail, and so on like this. It gives you this assignment operation. So now, as I was mentioning sometime back about nested list, this is a typical example of nested list where you have some kind of matrix like this. You have the upper row as 72, 88, 91, the lower row, second row as 65, 79, 84, and the third row as 90, 92, 95, like this. So all these are typical examples of nested list here that you are having. So you are actually having a list within a list. So each item in the list is a list itself. So this is a typical example here, and you can actually index each item in a particular list of lists also. For example, marks of one actually gives me the first item in the outer list. So it gives me at index 1, 65, 17, and 84. But if I want to actually look at within the second list itself, the third most item within it. So marks one actually gives me 65, 17, and 84. And within that, if I again index it by 2, it gives me 84. So it's very typical how you do matrix operations. So similar to that, you can also do this here. So you can also iterate this thing called enumerate or zip operations. And these are typical examples here, which I'm showing. So given two lists of names is a string list, scores an integer list, you can do like kind of do an iteration across both of the lists at the same time, sort of. So these are the kind of operations. So you have like this. That is also other aspects of it. Like so, I'm skipping this exercise a bit. I think this I guess like we have already done this like did a rough pass through of this kind of exercise already in the previous two slides. But this is a very similar kind of exercise itself as compared to that. So up till now, any questions here? So if there are any questions, feel free to ask. We'll now move to tuples. Um, any specific questions? Sure. Okay, the matrix was not understood. Okay, I will just go run through that matrix example once more. Anything, any other questions in the chat? If you have, feel free to ask. I will try to share a PDF version of the slides at the end of the talk. Yeah. Okay, so let me go through the first question, the matrix question itself. How do you, yeah, so What we're trying to do here is that we want to construct a 2D matrix here, which consists of rows and columns. So my matrix is like this, that I have 72, 88, 91 at the, so this is a 3 cross 3 matrix. 72 sits at the topmost left corner, 91 sits at the rightmost top corner, like this. So 72, 88, 91 is the first row, 65, 79, 81 is the second row, and so on. Now, you can represent this kind of matrices as a list of lists also. So each row is like a list, and each item in the outer list is actually a column. So, it's the row itself. So, uh, if I'm able to explain clearly, what it means is that the outer list here, which opens at the first bracket and closes at this bracket, consist of items which are basically rows in the matrix. So each row is like an item in the matrix. Each row itself consists of the columns at that specific row. The integers lying at all the columns at that specific row. So 72, 88, 91 are first column, second column, and third column, lying at row 0. Row 1, 65, 79, 84 are similarly the numbers, and so on like this. So if you want to go to a specific item in the matrix, let's say specific integer in the matrix, let's say 84, how you can access is that you can first give the row ID and then the column ID. So the row ID is 1 here, and then the column ID, which is 2. So you get marks 1, 2, it returns back your 84 as a integer that you're trying to retrieve. So this is basically how you can represent a matrix in a 2D matrix uh, uh, in Python. Okay. Does that mean if len equal 3? Yeah, I think you can also do this where if you don't want, if you just I so basically sorted, for example, if you want to sort the entire list, so there is a question in the chat. I'm just answering that question. So sorted, if you are trying to sort a list, you can add sorted operation and it sorts your entire list. But if you, let's say, want to only sort, let's say, the first 3, 4 items in the original list, what you can do is that you can slice the list and you then sort your that sliced portion only. So you can do that. Or yeah, so you can also get a slice of that list itself, get the subset or the subsequence, and you can apply your sort only on that subsequence also. So that is also possible. Okay, so we'll move ahead. So now we'll look at tuples. Tuples are very unique also as compared to strings and lists. So you can think of an application um, like in geometry, let's say, when you plot some kind of function, let's say a parabolic function or a ellipsoid or ellipse and all those kind of things, you actually specify your x and y coordinates. Or if it's in a 2D space, let's say, if it's in a 3D space, you specify x, y, z, your 3D coordinates, 3 coordinates. Likewise, you can consider a tuple as a kind of this kind of representation of a particular, let's say, an item or a point. For example, point 3 comma 5 is a tuple. I'm representing it as within this parenthesis 3 and 5 and separated comma. So it only indicates a particular variable, but has this two sort of properties 3 and 5. Similarly, colors that I'm showing here is is a tuple of, because I'm just separating it with a different this thing. So there is a typo here. I forgot the parenthesis. It should be closed with the parenthesis here. So there is so likewise like this, you can have multiple such things. So if you have only a single item in a tuple, you need a trailing comma. So one item like this, like 42 comma you have. But if you don't add a comma, it's not a tuple, it's simply an integer. So which we are showing here. So so some examples here, let's say I have this initial tuple called record, which is Asha 2188, and I can actually separate out each variable in that tuple. So I can do name, age, score, and I can just assign it to record. Name would be assigned Asha with the string variable. Age would be assigned 21. Score would be assigned 88. Now, what I'm doing is that, so this is something called unpacking, which we are showing. This is an example. So if you have a group of values that you have, you want to unpack each values in the tuple into specific components or specific variables. So that's called unpacking, which we did. Now, you can also do swap operations also. Like for example, this which I'm showing here, like a comma b equal to is 1 comma 2. You can swap these two operations, like two variables. Like so, initially a is assigned to 1 and b is assigned to 2. But if you want to assign a equal to 2 and b equal to 1, you can just simply do a comma b equal to b comma a. So what it does is actually a is assigned to the value of b is assigned to the value of a. So this is just a Python swapping technique, and it uses tuple unpacking as one of the inside operations for doing this. So that's one of the aspects here. Um, so yeah, so when is your tuple kind of a right choice for your application? So for example, you have a fixed record and you have some kind of position that has some kind of meaning. For example, coordinates, as I was mentioning. Like if you have a plot on a 2D space or a 3D space, you have coordinates associated with a point, let's say. So that has kind of a meaning because you have a particular position assigned to that point. RGB values like red, green, blue values, or in a pixel, let's say, in a image or something, it also has a particular meaning to it. So let's say you have an image pixelated data, and each pixel has a corresponding RGB value associated with it. So you can't actually separate out the red, green, blue values like that. You actually have to consider the three color values together to consider a particular item. So that's your kind of single item representation using RGB. Similarly, database rows or is also another example where you actually, let's say you have a financial data set or Excel sheet, let's say, where each database row is actually a particular entry in the credit card statement or something like that. So you can't separate out the items because one item separation from the other actually doesn't hold any meaning. So you have to consider the entire thing together. So in those cases, you can consider tuple as one of the choices for storing your data. You can also have multiple return values also, like even a function. So we'll look at what definition of functions later on, but just to give you a brief preview of functions. So in functions, you commonly return a tuple also in some cases where you want to unpack into several variables. So that there you can use a tuple. You can also use it in a dictionary key. Dictionaries we haven't studied yet, but you'll see like there are also tuples are used very like in many applications of dictionaries, tuples gets used. So yeah, so with that, I think let's move on. If there are any questions, yeah, there are no questions now. So given this x is equal to 10, 20, 30. So again, please consider this. I think I kind of forgot the parenthesis in the variable. So yeah, so it's actually a tuple with starting with a parenthesis 10, 20, 30, and then a closing parenthesis. So I think it didn't show up in the slides. So this is a tuple, and ABC is equal to X basically means A is assigned to 10, B is assigned to 20, and C is assigned to 30. Now, our goal is to show this that X0 is equal to set to 99. That means my first element in the tuple is set to 99, and I'm trying to print the type of the data type X here, and I also want to print A plus C. So I want you to answer like which line would actually fail if I uncomment everything. Let's say I comment either the first line or the second line or the third line. Which do you think is the erroneous line here in this setting? Yeah, someone said the first line. Anyone else wants to try? Okay. So the first line itself is would be an error here because you're trying to assign a tuple and you're trying to kind of like predict before running the thing itself. So um, yeah, so that's the setting that you are having here. Any guess? So with that, I think we are ending with tuples. Tuples, I think, is a very short aspect because it would be used mostly in dictionaries also. So we can take in some more questions till now, like from strings, list, and tuples. Overall, if you have any questions now, you can ask. Then we'll cover dictionaries, and that will be mostly the end. Uh, there is some few more concepts we'll discuss for next week also. So take in some 2, 3 questions now. So if you have any questions, feel free to ask. So I think there are a few questions coming. So one of them is are tuples mutable or not? So we actually showed in one of the examples. So tuples are not mutable, so they're immutable. So you can't change like directly assign a new variable, new integer, let's say, or new string to an item. Okay. Any other questions? Okay, I think then we can move ahead. If there are no further questions. Okay. So I think we'll move ahead with dictionaries now. Um, so these are like the mutable data types in the sequential data types family. We can actually update a particular item in the dictionary data type. So we'll look at how to create and update mappings in a dictionary. We will also look at how to access missing keys safely in a dictionary. We will also look at iteration through records and also nested data structures. Sure. So as I was mentioning, nested lists in the previous list topic, there is also a nested dictionary or nested lists that you can have in a dictionary as well. So there is a typical example of a dictionary that we are showing here. You have student as the dictionary variable. Within each of it, you have a key and a value mapping. So the first key is name. The value associated with it is Asha. The second key is age. Value associated with it is 21. The third key is score, and value associated with it is 88. So these are like the key value mappings that we have in dictionary, where I have a corresponding mapping between the key and the values. So typical rules for dictionaries or for keys in general, like keys must be hashable. Keys are unique. For example, you can't have two same keys in the dictionary. It has to be unique. So you can have strings, numbers, and tuples are also as common keys. And you can only access by the key name only. So, for example, you can't access directly by the value. You can't access by the numeric position of the index, like in list or string, where you typically index by the first position or the second position. You can't do that in a dictionary. You have to do it via the key which is provided. So, for example, if I want to retrieve the value 21, I have to sort of access it via the key age. I can't do student 1 as the indexing operation here. So, the use of key value pairs you do inside in this second bracket braces. You access it via dictionary key aspect, which I'm showing here, like this. And what you do further is you uh, can like I'm showing some typical operations in the dictionary on the right hand side. So you have this dictionary here like this. You can do student name that accesses the dictionary via the key name. It gives you back Asha. You also do lane of student, basically the number of dictionary entries is the length of the dictionary data type. So there are three entries here, so there is three. Now you can also do score in student or not. So what you are doing here is that, well, the key score is present in the dictionary, so it's true. You can also do 88 in student dot values. So student dot values actually is a list of the values in the dictionary. So it gives you back uh, the list of the values. So when you do 88 in the student dot values, it basically means that 88 is present in the list of the values or not. So it's also true because 88 is part of the list itself. So that's all. I think now we'll look at since we mentioned it's mutable, like you can also directly assign and change it. And you can also update, you can add, delete, also operations you can do. So for example, I want to add a new key value mapping to the student operation, a student dictionary variable. So I can do student.update and add city as a key and value as Pune. And I also can add another dictionary item active and true. Now, for example, I want to remove, let's say, a particular or delete, let's say. Now, so for that, I can just use the pop as the sort of the operation with the corresponding key name associated with it. So I want to delete city Pune from the list of items here. So I can just do pop city. it removes the key as well as the corresponding value associated with it. You can also delete, use the DL operator also, which removes the key. And lastly, you can also use clear, that removes all the pairs and gives you back an empty dictionary. So yeah, so that's the kind of setting that you have. And since also pop, actually in previous settings, it you can also, if you do student.pop, it returns you the value corresponding to it. So you can actually assign it to a variable and you can print it also. So that's basically the operations about, and like addition, update, and all those things. You can also do like retrieve, let's say retrieve in the sense like you can access specific values in using these different operations. So sometimes when a key is absent, if you try to access the dictionary with that key, it gives you a key error message. And so there are multiple operations there, like let's say when a key is absent, you want to add a default key to it. Instead of giving you the error, it actually gives you back the default key value mapping. So you can do different kind of fallback operations like this. In case a key is missing or you don't want to get the error in an application, so you can add these things. So you can also iterate through keys, values, and items. So for a very simple thing is that for key in D, for key in D in the dictionary, you just are iterating through the entire dictionary via the keys. If you do dot values, it gives you back the list of values. So it becomes a list. You can also iterate through that. You can do dot items. It gives you tuple kind of key value pairs. You can also, so it's a tuple of data type now. If you do scores dot items, let's say, it gives you these key value tuples. You can unpack them as we are showing in the previous tuple slides, as well as do a loop operation across. There is also dictionary comprehensions, which we saw in list, in case of list also. Here also is possible. So on the right, I'm showing you a few example here. So let's say I want to have scores and names are the initial dictionaries. I want to have a score name kind of mapping now. So these are like scores and names are like initial lists actually. So you want to create a mapping dictionary out of it. So what you can do is that you can do for name and score in zip name score. So that means that there are two iterations happening over names and scores independently. And for each item in name and corresponding item in score, you are assigning to it. So you are assigning Asha to 88, Mira to 99, 91, and so on like this. And at the end, what you are doing is that now you get a dictionary called score map, and you want to now apply a dictionary comprehension on top of it. So the first one was a list comprehension, and using that you are creating a dictionary. Second one operation is a dictionary comprehension, where you are looking at name and score in the score map dot items. So I was mentioning score map dot items returns you a tuple, and you are now doing this unpacking, tuple unpacking operation here. So name and score in score map dot items basically means that name is iterated over the list of keys and score is iterated over the list of values. And wherever my score is greater than equal to 40, I'm just returning that in the dictionary. So uh, only 88 and 91 are the score values of the scores that are greater than 40, equal to 40. So I'm just returning those key value mappings here. I hope this operation was clear. I think this is a very might be a mid difficult example, but this is the typical dictionary comprehension operations that are there. So now we will look at something again called nested dictionaries. So we looked at nested lists also in previous slides. Now there is this nested dictionaries. So you can have a dictionary within a dictionary itself. So on the right, I'm showing you an example. So you have students as a outer dictionary. Within each within the dictionary itself, you have two items. Each item is a dictionary itself. So S01 is a key, and a corresponding value for that is again a dictionary. So S01 is a key, name, Asha scores, the entire dictionary item, the sub dictionary thing is a value for S01. But S02 also is the same thing, is a key in the outer dictionary. The value within it, name, Kabir, scores, and all is again a dictionary itself. So these are like nested operation dictionaries. So if you want to, let's say, get the scores of Kabir, let's say, how you do access it? You just do score students, you go to S02 as a key, you get the corresponding value associated with S02 key, which is the second dictionary. For that, you again do scores. Scores is the corresponding key that you have within that nested dictionary. You get 75 and 80, which is a list. Now you want to retrieve the the second position item in the list. So it gives you back 80. So this is like very useful when you are actually reading JSON kind of files. So like parsing JSON files and all, you need a nested dictionary kind of data structures. And also typically data are organized in a hierarchical fashion. So there might be different nested information within the data. So how do you represent it well? You can do it using this kind of nested dictionary mappings. We'll look at data frame, pandas data frame, and all those libraries at the end of the course also. Where we will see like how you can use this kind of dictionary operations there also. So the data frame library also uses dictionary comprehension in their internal operations. Okay. So you can also merge two dictionaries and also copy records. So let's say I want to combine two dictionaries together. So I have base dictionary, I have an update dictionary. I actually do merged um, thing here. So it actually does my uh, kind of like merging the two operations together. But if there is a kind of a duplicate key in both the things, the right hand value gets the assignment. So let's say score and score are both same duplicate keys in base and update dictionary. I 490 gets updated in the final merged operation. So this dash uh, the straight line is actually this merged operator in case of dictionary, and you can again do some kind of mutable properties that you are showing here. So that's mostly it. And so, so there is a small exercise. I would like you to try it out at your end. And if you have an answer, feel free to share in the chat. I will have a look at it. Yeah. So we'll take like 2 minutes to solve this. And if you have any answers, please feel free to share in the chat. Okay, I think we will look at the answers in the chat. But I think people haven't posted it. So if you are taking some time, feel free to click on it. And, like it's written, the expected results are written, but I want to make sure that you are able to get the answers, why you are getting the answers. Uh, Um, okay, I think we can move ahead now. I think if you are able to solve it, that's good. If you are not able to solve it, please you can check those resources online once to figure out. So yeah, let's move ahead. We'll only have 15 minutes or so. So we'll wrap it up with uh, the last item, which is sets. So as I was mentioning, sets are like more like a different kind of data type, uh, where you actually want to include unique hashable values. So as opposed to dictionary, which was more about unique keys, you now have kind of only want to have unique values within this data structure. So that's your requirement here. And so you want to remove duplicates. For example, you originally had a list of items which had duplicates in it, and you want to remove them. So there you can use sets as one of the operations. You can also try to see if you want to check for test membership. Let's say whether an item is in the set or not. You can easily do that. Although you can also do this in lists and other things, you can also do set algebra, like complement of a set, and also things like set difference and all those things you can try out in all these set algebra operations you can try out there. So all those things are possible, and you can also do different kind of ordering limitations, which we'll see more from the upcoming slides. So, for example, if you want to create a set So typical set is like this, like tags, Python, NumPy thing within second braces as follows. And you can also create an empty set via the set operations and just do the parentheses shown here. It gives you an empty set. It just creates that thing, and so you can add also items in the set like this. Or you can do a predefined collection of items in the set where you have 72, 88 like this. Note that you have a repeated element here. Like 72 is a repeated element here. So in your set, you only get 72 and all. And so you won't get the repeated elements in the set anymore. So yeah, so this is some of the things that you are there here, and you now have to look at this thing called membership and mutation. So, for example, if you want to add a new element or insert a new element, you can update many in or insert many items at the same time. So, for example, if you want to add, you can do dot add, and it would add you this item in the set. You can also do an update where you can add multiple items at the same time. So you want to add git and pandas to the initial set, you can just do update. You can do membership test, like whether Python is in the set or not, which is true, it returns you true. You can also remove things. If so, you can do, let's say, discard Excel. Excel is not the part of the original set, but so it doesn't do anything. But if it was part of the set, it would actually remove that. You can also do remove and all those things up there. So it is very common with the other data types also. Now the important aspect is called set algebra, which everyone knows here, like set operations like set union, set intersection, and difference, symmetric difference, and all. So you can do all those things between two sets in Python. The given two sets, you can do union operation, you can do intersection operations and all. So those things are possible here. So basically, like if you have like duplicate values, let's say you want to deduplicate those, so you can use set. As I was mentioning, like it removes the duplicate values. If you want to find unseen categories with some, let's say, differences and all, then also like different like topic exploration kind of applications where you have recommendation systems and all those things. You can actually apply set as one of the data structures there, and so on. All those things you can try out. And so here, for example, I'm doing a set operation like observe minus allow. I can also do a sorted operation on a set, which is just sorts by the ASCII kind of ordering. And so because it's just a string, so it gives you the ASCII based ordering and all. You can also do set operations as I was showing, and so on. So we'll skip the set exercise for today. We'll go to the last one, which is range and typed arrays. And we'll quickly go to NumPy array after this to end the session. So range start and all. So range is very simple, like it's similar to slice. You start, give it the start position and the stop position, and also the step, which is like at how many intervals you want to have. So for example, 2, 5, 2 and 15 and 3 basically means all the items between 2 and 15 at intervals of 3. So 2, 5, 8, 11, 14 like this you go. So why range is efficient? Because it stores the start and stop and step. So you don't need every integer within the thing itself. So you can just specify start, stop, and that's all. It supports len operation, indexing, slicing, membership, and iteration. All those things is possible. You can also, if you need a list of the numbers between that two intervals, you can convert it to a list also. So that is also possible. So basically, range is like a lazy in storage. You're not storing the entire numbers between the start and the stopping positions. You're just specifying the range. So it's not actually storing all the numbers, but it's a sequence object. It falls under the sequence data type family. So you can use range in loops, indexing, reverse progressions, and all those aspects also. So in loops, I think many of you have already seen probably if you have some understanding of Python, like you have this loop operation where you have for I in range 3, so which is with where range is used within this for loop. So likewise, you can use it in different as cases where even in the list comprehensions as well as the dictionary comprehensions we were seeing, you can use a range there. Membership is also efficient because the range actually gives you a sorted list, so you can do memberships easily there. Basically for membership, what you have to do is that you do a linear search across the list actually. So it's an order of n in that case. But since range gives you a sorted thing, you can do a binary search and gives you in log n time. So membership is much more effective and efficient for arithmetic sequences there. And you can do slicing and all those things also in this thing. Now we'll look at array, which is slightly a primitive version of NumPy array. It doesn't have the NumPy libraries functionalities as such that much, but you can have array as follows. Like you can create an array like this. You can append new items using dot append. You can also mutate by assigning new value to a particular item like this. And you can actually have an array of mixed types also. So you have this array here of strings and integer list. So you have the first item in the array is a string. The second item is a list. Within the list also you can have different things. So this is like a multi-dimensional mixed container. You can have multiple such data types within the array. Okay, so now I think we'll skip this a few slides and then we'll look at NumPy now. Although I think we won't be able to cover everything today, I will cover in the next week some parts of it. So NumPy is very much popular in data science, and people who have already in the audience who have already used NumPy previously, they probably know like why it's useful. But for newcomers and who are getting introduced to Python, I want to just share a motivation for why people use NumPy for data science. Firstly, it provides a very compact storage facility, like elements share a data type and they're stored in regular memory layouts. They also provide vectorized operations that you can do the whole array operations. Like if you, let's say you want to add uh, like uh, uh, like add 5 to all the items in the array, let's say, which was some of the operation example we saw earlier. Instead of searching through the entire array, you can do it quite fast using vectorized operation. It supports n-dimensional data, like multi-dimensional data, like vectors, matrices, images, time series data, tensors, and all. And also there is scientific ecosystem around it of Python of NumPy, like scikit-learn, pandas, SkyPy. Many such machine learning tools use NumPy very heavily. So there's a huge scientific ecosystem around NumPy. So it's useful to learn NumPy if you're willing to contribute to machine learning and all going forward. So so with that, I think we'll go forward. So NumPy is a packaged library which is available in Python. You can just import the library as import NumPy. You can, like people usually do in code bases where they add a alias of NumPy as NP, because you don't have to call NumPy the entire thing over and over thing again. So you can just abbreviate it as NP and just make the function calls based on that. So if I want to create a array, let's say np.array, this thing, it gives me an array of 10, 20, 30. If I want to create an array of zeros of then it of total number of items in the array is 4, like 0, 0, 0, 0, then I can do the np.zeros 4. I can also do a matrix in a NumPy array. So np.ones basically means a 2 cross 3 matrix where all the entries are just ones. So it gives me this kind of thing. You can also do np.arrange and line space, which is similar to range, but a bit different, but it's similar to range. So I would like you to go through the sort of the documentation on NumPy to understand this more. We'll kind of stop at this particular slide for this week. So this is a typical NumPy array, which is a multi-dimensional array, uh, where I am kind of representing a 2D matrix here using a NumPy array. And our goal is to show that how you can index it better, as well as different operations that you can have. So the number of accesses like ndim is set to 2 because dimension is 2. Size is equal to 6. Basically, that means the total number of items in the NP array. Shape basically means the 2 cross 3 matrix shape. D type basically means the item, each of the items in the NumPy array, what is the type. So it's an integer, so it's an integer 64 type, and so on. So this is basically the overall anatomy of a NumPy ND array, and we'll look at some of the operations in the next week a bit more. So yeah, so that's all for today. I think we covered a lot of topics today, like strings, list, dictionary sets, tuples, and also some aspects of array. And so this is something that we kind of have gone through. Many of the operations are kind of common across multiple such data types. There are a few operations which are very unique to specific such data types. So we'll cover some of the remaining topics going forward next week. Although NumPy array is a topic for next week also, so we'll cover the items there. And with that, I would like to thank all of you again for joining for today's discussion and staying back and going through that, I think. So I look forward to everyone having you next time, next week again, same time. So for people who have joined late or maybe people who don't know me, so I just want to again give an introduction. So I'm a PhD student at IIT Bombay. I'm studying computer science and engineering at IIT Bombay, and I work on machine learning and AI, particularly on language models, how to build efficient language models in this space. So I heavily use Python in my research and code. So this is very useful. Like all the methods that I'm talking about are very much applicable to this aspects. So that's my intro. So for people who don't know, so I will be taking the third week session again next week, Saturday, same time, 3 to 5, and we hope to discuss the next set of items on NumPy array and other things, functions and all those things the next week. So thank you again for joining. So we'll be ending the call in 2-3 minutes more. We'll end with some questions. If you have any questions or something, we'll end with that. So if there are any pending questions that you want me to answer, feel free to ask. We'll meet again next week. Thank you. Yeah. Yeah, I'll send the slides of the session in the chat now. Just, just download it. Let me just stop sharing first. Um, yeah, I'm trying to attach the slides in the chat. Let me just try to. Just a moment. I think I will just share the slides, Google Slides link itself. I think I'm not able to attach the PDF file itself. I'll just share the Google Slides link. Um, if you're able to access it, I'm just sharing it. If you're able to access it, just let me know, like with a thumbs up or something. Okay, I've shared in the chat. If you're able to see my slides. Okay. So I think the recording for the last session, let me just share that also. Give me a moment. I'm just trying to share the recording of the last slide. Yeah. Let me share in the slides. Let me share the link. But I think there was a network drop trend. I think you probably if you're able to hear me. I've shared the week one recording also in the chat. Feel free to go through them at your own time. We'll meet again next week, and thanks again for staying back and staying part of this course. So we'll meet again next week. Thank you, everyone. Bye.